This multiplying of polynomials also has a connection to geometry. And so this last example for lesson 3.3, example 4 in our PowerPoint, is going to give us an example of how we can apply this to a geometric setting. So we have a rectangular piece of tin that is 16 inches long by 12 inches wide. And each corner of that rectangular piece has a square that's cut out of it, and each side of that square is x inches. We don't know what x is. Well, those squares are cut out, as you see in the diagram, and the edges are folded up on those dotted lines, and they form a box without a lid, without a top. Okay? We want to determine the volume of this box. So we've got to picture the fact that this red rectangle is the bottom of the box. And we can find the area of that rectangle by taking length times width. The volume then is determined by multiplying by the height, which is going to be equal to this distance here that I'm putting in blue, because these are folded upward to form the sides of the box, and so those become the height of the box. So the volume of a box is just going to be length times width times height. So now we have to determine what's the length of this box. So the length of that red rectangle. Well, the original length of the tin was 16 inches, but we cut out an x on the left side of that, and we also cut out another x on the right side of that. So we cut out two x's to form the length of the red base. So that means the new length of our red base is going to be 16 minus 2x. We can do something similar to determine the new height of that, or width of that red box. The width of the tin was originally 12 inches, but we took away an x from each end of that 12 inches. So now it's 12 minus 2x. And the height, of course, is just the blue length there, which is just, I was told, or we were told, is just x. So what we have to do is multiply these polynomials together to get the volume of this box. So I'll start with the two binomials. I'm going to distribute the 16. I have to multiply the 16 by the 12, and I get 192. And then I have to multiply the 16 by the negative 2x, and I get minus 32x. And then I have to distribute the negative 2x. Negative 2x times the 12 is negative 24x. And negative 2x times negative 2x is positive 4x squared. These, of course, are like terms because they both have an x to the first power, so they can be put together. So now I'm going to have 192 minus 56x plus 4x squared. That's my length times my width. But that, we remember, has to be multiplied by my height. So we're going to have to multiply that answer by the height that we have of x. So we're basically just going to distribute that x. So when I multiply x by 192, I get 192x. When I multiply the x by the negative 56x, I get negative 56x squared. And when I multiply the x by the 4x squared, I get positive 4x cubed. Now what's nice about this is now we can say, all right, so let's determine how to maximize the volume of this box. How big of a square should we cut out of each corner of the piece of tin in order to get the maximum volume, in order to create a box that will hold the most stuff? And we could play around with this by plugging in various different values of x to determine the answer to that question. But we'll save that concept for a later lesson.